This video will address inductors within DC circuits. An inductor is a two-terminal electrical component consisting of a conductor, usually wound into a coil. Simply, it's a coil of a conductive material. This simple device uses a flow of electric current to store energy within a magnetic field. There are three laws relative to inductors. Firstly, it's inherent to understand that every moving electron produces a magnetic field around itself. Secondly, it's important to understand Faraday's law of electromagnetic induction. And finally, but less importantly for DC inductors, Lenz's law states that the direction of the induced EMF will oppose the change that caused it. As current flows through an inductor, the movement of charge produces a magnetic field around this inductor. It's this magnetic field that stores electrical energy. When the inductor stops charging and a current is no longer applied to the device, the magnetic field will induce a voltage into the conductor and a current will flow. This is how the inductor releases its energy into the circuit. Within DC circuits, as there is a flowing electric current, an inductor will store energy within a magnetic field. However, unlike AC circuits, an inductor within a DC circuit does not have a resistive value, known as impedance. This is due to DC being a straight wave, as can be seen below, and thus not having a value of frequency. As a resistance equals 2 pi times the frequency times the value of the inductor, as frequency equals 0, the resistance equals 0, and there is thus no impedance. Why DC is different to AC? As can be seen by Faraday's law, as stated before, within an AC circuit, as the current constantly changes in direction, the magnetic field constantly changes, causing relative motion and thus a voltage to be applied to the conductive wire. In relation to Lenz's law, the induced current will oppose the flow of current that caused it, creating resistance. This resistance is known as impedance. Within a DC circuit, there is no changing current and thus no changing magnetic field. There is therefore no voltage induced into the wire. In turn, this means that an inductor in DC has no impedance value. There are many different uses of inductors in DC circuits. Due to their energy storing ability, they can be used in a widespread array of technologies such as transformers, electromagnets, or electromechanical relays.